Hi students, now we'll talk about components of vectors, which is section 1.8, and this section is in page number 14 in the book. In general, we will see different vectors and different lengths and different directions. For example, this is vector C with length 12 unit, and its direction is 60 degrees below the horizontal. This is the vector F, and its length is 20 units. Maybe it's in meters, kilometers, or it's speed, velocity units, or force units. And its direction is 30 degrees below the negative or the left horizontal line. This vector direct 30 degrees above the right horizontal line, this, and so on. Horizontal line, left horizontal lines, vertical line, all of this can be embedded in the XY plane. As we see here, this is the vector B. Its length is 15 meters, and its direction is 30 degrees to the right of the y-axis. Vector D with length and the direction of it is 53 degrees to the left of y-axis, and so on for each vector. This vector A with its length 8 and its direction downward or negative y direction. This is negative y direction. This is negative x direction. Also, there are different names for the axis. This direction we can call it east also. East. Also right. This is west or left. This is upward or north. This is south also, okay, or downward. Sometimes we can say that the vector B is northeast, but what is the direction in degrees? We need to know the direction in degrees. For right triangle, if we have a vector, and the vector in general will draw for us in the XY plane a right triangle. This is the vector A. This is the vertical component. We can name it AY. This is the horizontal component. We can name it AX. A in the direction of X. The component, if we have a vector like this and we drop a stone from it, it will reach the X component. And if we drop a stone on the y-axis, it will reach the y component of that vector. For a right triangle, we know the relations sine, cosine, and also tan. Theta. Where is theta? This is theta. Theta about one of the x or y axis. In this drawing, you can see that theta from the y axis. You can see theta from the negative x axis. For A, its theta with negative y-axis is 0. Now we can call this angle is theta. In general, we use the positive x-axis, and measure the angle from the positive x-axis counterclockwise. So sine theta, as known, is ay over a, and cosine theta is ax over a. I mean by a here, this is the vector a, but I mean the length of a. If we need to talk about the length or the magnitude of a, we put it between two vertical lines. So b is a vector, its length is 15, so b magnitude is 15. Here a magnitude between two lines is 8. From these relations, sine theta is equal to the opposite over the vector length. Then we can find sine and cosine relations, and we can find the ax and ay components, the xy components for the vector, which is equal to, if we take, for example, sine theta is equal to ay over the length of a. This is over 1. We can use this process. Then ay is equal to, multiplied by 1, is equal to the length of a multiplied by sine theta. And we have the ax component, which is equal to a, the magnitude of a multiplied by cosine theta. Ay component is the magnitude of a multiplied by sine theta. And by the way, tan theta is equal to ay over ax. And the Pythagorean theorem, which is ax squared plus ay squared is equal to the length of a squared. Okay, now let us look at this example here. If we have a vector r, the length of r is equal to, by using the Pythagorean theorem, as we see here, rx squared plus ry squared, but all under the square root of them. If we suppose that, for example, ry is equal to 5, rx is equal to 7, and we need to find the length of this vector. The length of this vector is equal to the root of 5 squared plus 7 squared, which is equal to 25 plus 49, which is equal to the root of 74, which is equal to 8.602 and something. We can round these values. After the 0, we can take it 8.6. Can we find the theta? Yes, we can. We can use the trigonometry relations. We can use tan theta, which is equal to opposite over the adjacent, which is ry over rx. Okay, ry is 5, rx is 7. Tan theta is equal to 5 over 7, which is equal to 0.71428 and so on. We can also round it. Theta, we can use the inverse function from the calculator, which is sine inverse, cosine inverse, tan inverse. We are dealing now with tan. If we need to find the theta in degrees, you need to be careful. You may work with radians or with degrees. Now I'm working with degrees. So tan inverse to 5 over 7. This is the angle, 35.53 and so on. This is the angle in degrees, not in radians. Okay, this is the way how to find the theta angle. We will solve more examples to make it more easy. Look at this example now. We need to find the components of each vector, given vector. If we have the vector F, denoted for the force, and we measure the force by Newton, we will come to it in its time. If we have the length or the magnitude of the vector force is 316 newtons, and the angle from the positive x-axis or from east is 35 degrees. We need to find the components. The components are the xy components. Fx, as we know from before, is f cosine, the length of f or the magnitude of f cosine theta. Fy is f sine theta. This is fx, and this is fy, which is the same length like this one. Okay. From the direction of the angle, always we will use cosine. Okay. So if x, that magnitude of f is 316, cosine 35 degrees. We need to be sure that our calculator on degrees. We will use radians later. So fx now is 258.85 newtons, and fy, which is 316 multiplied by sine theta, sine 35, which is equal to 181.25 newtons. Now we find fx and we find fy. I need you to note that in vectors, if you add two vectors together, the resultant value, it is not as the scalars. Add them together. Note that fx plus fy is not equal to the magnitude of f. If you add them together, it will be 440.1. It is not equal to 316 because there is an angle between them. They are not in the same direction. If they are in the same direction, then the resultant value will be the same. For example, if we have this vector is 3 meters and we have another vector 5 meters in the same direction, this is A, this is B, then A plus B is equal to 8 meters in the same direction. We need to put the direction which is in positive x direction. Let us now look at this example also. Now we take the angle from the negative x-axis. We need to find the components. This is ax, this is the vector A, which is 8 in length. This is ax. Now the component of x, the x component is on the negative x-axis, not on the positive. And the angle from the negative is 30. And we need to know also ay, which is the same this magnitude. We can use this. Ax is a cosine theta, which is 8, the length of a or the magnitude of a in meters, cosine 30, which is equal to negative 6.9 meters. It is in negative direction. The negative sign in physics means that the direction is in the opposite direction from the positive direction. Okay. Also, ay is equal to a sine theta, a sine 30, which is equal to plus 4. It is in positive direction, not in negative direction. What if we need to use the angle from positive x-axis? We know that this angle, total angle, is 180. So this wrist angle is 150 plus 30, it is 180. What if I need you to use 150? It's easy. AX is equal to 8 cosine 150. It will give me the same magnitude, the same value, which is negative 6.9. Okay? Because the cosine of any angle bigger than 90, it will be in negative. Also, AY is equal to 8 sine 150, it will be plus 4 meters. What if you come and ask me, what if my angle is about is from the y-axis? I will solve it now. This is y, this is x, negative sign, and this is our vector A equal to 8 in length, and this is angle 30. What is this angle? This is 90, so this is 60. Okay, I need to find AY, and this is AX. Now I need to use the angle 60. I don't need to use the angles from the X component. Look, we know from before that AY is equal to the length of A sine theta, and AX is equal to A cosine theta. That is in the case that theta from X, taken from X, this is theta. But if theta is taken from Y, then we need to use cosine with Y, not sine. So cosine theta is used to the with the component that we take the angle from it. So in this case, in this example, we will use sine theta, because theta from y-axis, and here we'll use cosine theta. Again, you will see now, this is 60. This is AY is equal to A sine cosine 60, and this is AX, which is equal to A sine 60. This will be equal to A, which is 8, cosine 60 in degrees. Look here, cosine 60, it is half. Sine 30, it is half. When we take sine 30, it is half. Also, when we take cosine 60, which is the rest to 90 degrees, it is the same value. So it will be equal to 8 multiplied by half. It will be equal to 4. Okay? Sine 60 and cosine 30 are equal also. So this will be equal to 8 multiplied by 0.866, which is equal to, as we see from before, 6.9, but in negative x axis. Okay, in negative x axis. The third page here, we have three vectors A, B, C. You have the magnitude of each vector in meters, and you have the angles about positive x-axis, positive y-axis, negative x-axis. You need to try to solve and find the components for each of them. You need to find ax and ay. You need to find also bx, by, cx, cy. We will try to do that together in the class. Thank you.